Hello everyone, I hope you're all doing great. This has been a year since my mover and network prediction video. In my last video, I had a comment asking me about gas and network prediction plugin, and I said would be very unlikely and it would require almost a full rewrite of the gameplay ability system. To some extent that is true, but I am here to prove myself wrong, I guess. You know from the title of the video. So it is possible, and I'm here to show it to you. But before we get to the good stuff, I want to say a couple of things. This is built upon an improved version, I would say, of the network prediction plugin. These changes to the network prediction plugin include unifying the input handling, so simulation of the same player controllers send their inputs together. This can be improved a bit the way it's implemented, but it works. I just wanted to have something that works well, works good, works in a real world environment. So I don't want to make tools or anything that I will share with people that does not work in a real world actual game environment. Not in the editor, in actual shipped games. So back to the improvements, smarter input buffering that adapts to your ping fluctuation and packet loss, reduced the input lag. There was 1 frame of input lag, reduced the perceived lag of enemies from interpolation. I added delta serialization, which was kind of required for an ability system, and finally added support for lag compensation directly into the network prediction plugin.
It's me from the future. I actually forgot to say this. Uh, Unfortunately, starting 5.6, so this is built on 5.5. Like I said, the code is, or I will say the code will be available for everybody in a couple of days, but starting 5.6, the amount of plugins that you have to bring in into your project locally increases a lot based on which plugins you have activated. So generally speaking, now when you bring in Mover or the gameplay ability system, obviously if you bring the network prediction plugin, you're gonna have to bring in Mover. If you do, now Mover has a integration with Mass, and Mass has and smart objects and etc. So plugins, any plugin that references Mover is gonna have to be brought in, and any plugin that references that plugin that you brought in is gonna have to be brought in, and it keeps going. So this is one of the biggest reasons why I wanted to make something myself. And let me know in the comments after you watch the video, what do you think I should do? Should I try to improve this a bit and then leave it for the community? Obviously, I can't have full time supporting only this. I have bills to pay and a child to feed, but is this enough? Or should I try to make something like a new prediction system, a new ability system that comes with it that could just easily work with Mover and put it in the marketplace? I am curious of knowing what you think, so please let me know in the comments. Now we're back to the video.
Okay, so with these things out of the way, let's get to the good stuff. I chose to showcase to you today a few things that are mostly connected to movement, obviously. I'm not going to go into detail, this is just for showcase. If there is enough people who want to see more of this, I am willing to do more videos, more explanations, details, etc. The code for this will be available to everybody in a couple of days. I am trying to finish up documenting the code really well. Hopefully, maybe extract the documentation that I'm writing into the code. If there is demand for me to make actual videos, I would make, let's say, example videos of characters of your choosing from, I don't know, MOBA games like League of Legends, Overwatch. All a character like this, I would implement all of its abilities from beginning to end, everything it has, in a video so you guys can see how is the system actually would be used. With Now let's get to the actual showcase. So first, I'm gonna show you first in two screens so we can get this out of the way. So I can just focus on one screen from now on. So this works perfectly. You can see in the top right is my ping on each player. I will test later with a bit more packet loss. And you can see, so this guy is dashing. I press on the shift button, he dashes. I hold the shift after the dash, and now I'm sprinting. And when I let go, I am back to walking speed. That guy is just a bot going from one waypoint to another and will be useful for showcase later. So now we got that out of the way with two players. Let's just focus on one screen right now so you guys can see everything really well. Okay, my ping on the top right, bottom right is health, and that 300 is my current speed. Dash, and I'm sprinting. So let's quickly show you the ability. So this is the entire ability. Quickly, this is just setting up the mover component. And then I'm picking the montage based on the direction, WSND, camera. And these are the new prediction tasks. You are not allowed to use the old async tasks of abilities anymore. I will probably in the future, I will completely disable them from being used in this graph. This is a custom blueprint. It looks exactly like a normal blueprint, but it's a custom blueprint. It has its own custom compilation code, and mostly for these tasks. These tasks behave like active components. I'm not going to go into details. These are here for this class, for children. Once you add a node, a new one will get added. Its settings are here. You see them when you click on the node. They're also here inside of prediction task instances, which children can change. So this one is going to play a montage. This montage playback is actually completely synced within the simulation. So the actual playback happens within the simulation, and the result is published into the animation blueprint. The normal events for animation blueprints to play sounds and things like that work perfectly fine. There's no issues with that. But now we have the ability to roll back a montage, replay a montage. Even the montages themselves have something very unique, which I will get to right now. So montage blends out. If the montage gets canceled or the task itself gets canceled, you can cancel tasks by cancel prediction task by name, and you have the drop down of the names. You can also get prediction task by name, and this one is the only one that is named. And you can cast to the type of it and do expose things to blueprint, like jumping to a montage section. These kind of things you can do easily without any problems. One more thing about these tasks themselves, they are instanced object, and they exist for every instance of an ability. So every ability instance gets its own tasks. Obviously, you're not supposed to use these on the CDO. Any abilities that are not instanced are not supposed to use any async in them at all. They're supposed to be one shot. So by default, this is the whole abilities right now is set to be instance per actor. And now we're looking at our inputs. I'll get to the input in a bit. If our input is not triggered and is ongoing, this current input is a pressed input, so it calls started when the button is down, calls ongoing while it's down, and then triggered when it gets released, and then completed. So if the button is ongoing, so we are actually pressing the button and we're not triggered, we're going to apply a gameplay effect. This gameplay effect is just going to add some speed, move speed 500, and this gameplay effect has a query tag for removal. So if the owner does not have ability.sprint, this effect will automatically get removed, and this is how it's directly connected to the ability. So the ability gives the owner this tag when it gets activated, and when it gets removed, for whatever reason, this effect will also get removed with it. There's no special keeping the handle and then removing it. That's not necessary. So we also have this magnificent task of input, which in this case is using the ability input action. So whatever input action activated the ability, you can have multiple of them. So this will automatically use whichever one activated this ability this time in the current activation. And it waits for triggered, which is when the button is released, and completed or cancelled, whichever one comes first, to end the ability. If our button is not ongoing once the montage blends out, so we tapped on the button, we immediately end the ability once we blend out. And that is very much the ability itself. As for the part of the pawn, it's only this. On pre-simulation tick of mover, so add event, pre-simulation tick, I'm getting the settings, common legacy settings, which holds the max speed variable, and I am setting it to whatever the attribute is. And that's how you make speed based on an attribute. That is literally all there is to it. So this is how easy for you to work with movement and abilities if they were both using the same networking backend. Okay, I'm pretty sure right now the question in your head is, what the hell is this input? How is this happening? A quick thing about the input. Again, I can't go into details right now, so I'm just gonna go to the project settings, show you the ability simulation. Here I define all the input contexts that the ability simulation will use. And in the mover component, apply AMC, this is from the parent, it's just gets called on restart when the player controller changes. And I'm calling this add mapping context, which is a static function from the ability simulation library. Takes an input system and the ability simulation. This is really important to use this. The ability simulation needs to know when you add a context and when you remove it. So it needs to know which inputs is it listening to right now and which inputs it's not listening to. So you can obviously do this at runtime, but you can only do it on the local player because enhanced input local system is only for local player. There's also the ability to, for AI, to, or doesn't have to be AI. You can, let's say, you have some UI that has multiple buttons in it, and you don't want to simulate the UI or the mouse movement, etc. You just want to say, hey, the client clicked on this button. You can create either one singular input action with started, ended, etc. And you say, okay, started is for this button, ended is for the, or you create a single input action for each, and you can simulate the input triggers. So whatever input action, and okay, I'll make this an actual drop down. So that's how it works with the input. That's how simple it is. The ability can define the inputs that will activate it, and you can listen for whatever inputs you like. This one listens for the one from the ability, but you can define whichever one you like. We can also put this to end on triggered, so once it gets triggered, we end it, but it's best to let the ability end the task itself. Since I'm ending the ability, it will also end the task. And that's it for this ability. We go through it again. When I hit the button, I dash, and then I keep sprinting. So, but one more thing is, let's look at the animations themselves. The animations have no root motion. There's nothing in there. So you might be wondering, how am I moving? So I need to have enable root motion to tell the system that I want to use root motion. But it doesn't have any. So how exactly do we get the root motion? So let's go back to our montage and take a look at it. So we have this thing called synced skew warping. This is a notify state that mirrors exactly what motion warping does mathematically. So it will give you the exact same result. The only difference between it is that it defines the target to warp to at the beginning of the notify. So this notify state is what is called as a synced notify state, which means that it has simulation begin, simulation end, and simulation triggered. This is a uh, interface. It's not an actual class, so you can use any notify that already exists. You can add this interface to it and make it work with this instead. So if you have a bunch of animations that already have, for example, adding a tag at the beginning and then removing a tag at the end in a notify state, you can just move the logic from the normal notify events to the simulation events. And to give you an example of this, anim notifies. So this one produce velocity. It literally does what it says. It produces arbitrary velocity and moves you in the montage through this velocity. So if you see there's notify processor, simulation tick, simulation end, begin, and a restore frame. And these exist because there's also a function for get required type. And if you look, for example, on simulation tick, there is a sim input and a sim output. And these are, you can get the data. This has synced data currently. It's not very intuitive to use in Blueprint right now, but this is the best I can do given that I'm actually shoehorning the network prediction into the ability system in a lot of things. So notify state that creates root motion. Back to this notify state, test warping. Uh, this test warping one is a subclass, is already created in C++, and all you have to do is override initialize target data and update target data. It gives you a bunch of inputs, a bunch of things that you can use to decide. You can do traces here, you can do whatever you like here to find the target location that you want to go to in the world. Obviously, it has to be the root because it's exactly like motion warping. We're going to take the root of the character from here to that location. And the start location is the actor's location. I'm not updating here because the target location is static. It doesn't move. But if you have a target location that is, for example, based on the target actor somehow, an offset from him or something like that, you can update it here. Uh, that is it for the motion warping. We go sprint. We're done with the sprint and the montage. We go quickly to the other stuff. We're already 20 minutes in. Abilities and showcase. So I'm gonna go through this really quickly. This is just a simple ability. It has this so I don't have to create different abilities for each one. Uh, so let's start with multi-jump. Let's put this to multi-jump. And let's go do a couple jumps. So this has maximum 2 jumps. Doesn't matter how many times I press the button afterwards. And you can see apologies about that. Little technical issues. Okay, I hope I'm all good. I'm back. Okay, so jumps, double jump. We're doing great. Uh, let's go look at the double jump quickly. So this showcases something about the ability instances themselves are no longer replicated. So there is no replication of objects anymore. It's only the data, the states inside of it that gets replicated. So for an ability to represent its state, it has the tasks, which are the core of the system, which are able to rewind, replay, resimulate, do everything that is necessary inside of them. They have functions inside of them when you create them to define the behavior of what you're supposed to do, what is the data that you're going to use, reading the data, writing into the data. Everything is inside. This is highly inspired by the Overwatch talk of how they did their own abilities tasks. This doesn't have a lot of imperative scripting yet, but I think in the future, it would be possible to do things like while the button is pressed, ticked every frame, and when the button is unpressed, trigger a pin button is unpressed. So things like that. A pin that keeps triggering while something is true, that's imperative. Um, I'm sorry, I think it's declarative scripting. Yeah. So ability tries to jump. This is a synced variable. They are a subclass of specific type. I created one for so sync bool, byte, float, tag, integer, name, object, rotator, string, and vector. The collection is what holds a bunch of them. This doesn't support arrays yet, but you can create your own. You can subclass from the base type of this and create your own. So this is the sync variable, is just a byte from 0 to 255, and I just add it to 1. So if I can jump, meaning that my current jump count is less than my max, I will queue a layered move of a jump, which is a launch move that puts me up in the air by 800 velocity and puts my movement mode to falling. And then I increment my jump count. This is when I first activate the ability. And then I wait for the input, which triggered this ability, to get called started again. Again, this is a pressed, so when the button goes down, it calls started. So when I press the button again, I will try to jump again. And if I still have jumps, I will jump again. And then I will wait for the movement mode change. This is a really cool node that allows you to match between the current and the previous movement mode. So let's say in this case, this on mode changes will only trigger if the previous movement mode is falling. So once we come out of falling, we exit the ability. And this is the double jump. Okay, now this one is a bit of a flexing of what the system can do, but I might as well just show it to you. So manual velocity. This is practically just controlling the velocity of the character. I pressed shift there by mistake, but this is the ability. So it's like a dash, let's say. But I can control the velocity during it if I wanted to. Change my direction, do everything I wanted. So this how this works. It's a tick prediction task and a wait duration. So it will tick every frame. It's gonna put my velocity to the control rotation forward vector multiplied by some speed, 2000. And it's just gonna apply this velocity as a instant movement effect. Effectively setting my velocity, overriding my velocity to whatever I like it to be. And this is every frame. Once this duration ends, which is 0.4 seconds, I'm just going to reset my velocity to 0, put my movement mode back to falling, because here it's flying, and then end the ability. And this is pretty much it. This showcases the tick priority. For example, it's really important that this task ticks after this task. So when the end on the tick, on the simulation tick where this ends, we don't call the tick here. We just end the ability. Because if I queue this mode and this one, I am not sure which one will take over. Logically speaking, the second one that was queued should take over, but I have noticed that that's not always the case. So we're ending the ability after that period of time ends. And finally, targeting. So let's go over here to our little guy and just target him. The visual that you see is because it's printing on the fixed tick, but it's 100% between client and server exactly the same. And I'm going to explain the debugging and everything in a second. So this is what's happening. I'm targeting the floor, and if he's within that range, he will just get a little boop. So targeting. This is a task, wait input targeting prediction task, which has a confirm input, a cancel input. This is a, let's say, a variation of the base targeting prediction task, which its confirmation and cancellation are actually input pins. You can create these nodes really easily. It's just a class, it defines its start function, it defines additional input functions, and you just define your delegates here, and the node will automatically be created, just like the async nodes of the abilities. It will be, sorry, it will appear in this list. Uh, so these are the current tasks. I'm obviously not going to go into each one of them. We're already 30 minutes into the video. So tasks is going to do this is traced and overlap. These are a targeting processor which actually does the targeting. It gets all the events from started, triggered targeting, confirmed, all of these. And it returns to me the target data and whether it's a confirmed success, whether it's an ongoing success, etc. So this has a direction override where it will override the direction before doing the targeting to control rotation. And the location will be the actor location plus some offset. This is offset as if the character's rotation and location are 0, 0, 0, so they are relative to the actor. This goes 40 in the X, so 40 forward and 60 up, effectively putting this point on his forehead. And we have ignored actors. Obviously, lag compensation is enabled. And what you're looking at, what's happening to the bot is I'm getting the target data, which is actor target data returning. I'm going through all of them, and then I'm using this, get actor default state at time. So the targeting itself, before it triggers, it does lag compensation. So it will roll everybody back on the server, yeah? It will roll everybody back to where the client sees them. If they are within the supported rollback max rewind time in milliseconds. So if they are within this, they will be rolled back. Otherwise, they will stop at that time, wherever they were at that moment in time. This is to ensure there is some fair play between the shooter and the one that's being shot at. Not too much lag that if you're lagging too much, you can't just bring people back way too much in the past. This is obviously a choice of the person who's making the game. So this will do trace every frame on a line trace, and once I click on the button, it will check if that line trace hits something. If it does hit something, it will do an overlap in 300 units, sphere of 300 units, and it's only accepting pawn class. So that's how it works right now. So sphere checks everybody in it, and it will return to me everybody inside of it. But once it returns to me everybody, lag compensation has already done its job. We rolled you, we did the trace, we gave you the result of the trace. That's it. If you have hit results and you want to use the hit locations, etc., they will work perfectly fine. But if you want to use the actor's location, because the actors have now been brought back to where they actually are on the server, if you want to use the actor's location after the targeting, as in the lag compensation one, it's really simple function from the network prediction manager. You get actor default state at time. It's named default state because the lag compensation prediction task has a data type that you can subclass from and add other things like tags and etc. And it has a function inside of it, this struct, that tells me whether I'm supposed to roll back forward, roll back more or not. Again, this is also inspired by the Overwatch implementation, and this means that if you have a character that has some kind of ability that
once it's been accepted by the server, you don't want to roll that person back. I give you an example, a teleportation. If you have an actor that teleports or becomes immune to all damage, if the server accepted the immunity from that actor or accepted the teleport location, it's not fair to roll that actor back in time before that happened and shoot him. Because it's going to feel like I had immunity of all damage, it was accepted, I can see everything around me, the effects, all of it in the UI, and I still get damage. That is a no-no. So you can override this to create your own class, subclass of this, and for example, have tags inside of it. So there is a function inside of this lag compensation component that you can override to fill this data. It's called differently for simulated proxies or local player or server. So it's the same function, but it's called at different times. This one right now just gets the actor location, rotation, his capsule or collision extent. So if you want to roll back the collision as well, like from crouching to standing, all of it is possible. And it's all built in the system already. So if you just want to use the location, rotation, like the transforms and the capsules, this is more than enough. So what this will do is it will get the actor state at this time. This is just an all-encompassing function that you can call it on everybody and it will give you the correct value for each person. So obviously abilities only run on the client and the server. All abilities can be predicted. Everything can be predicted. Gameplay effect, execution, everything. There is nothing, anything that was not predictable before is now 100% predictable in the ability system. And this is what the debugging that you saw. It just gets the actors at that time and where he was at that time. For the player, just keep in mind, for the player, this is now. When the player calls this function, that player is the enemies, like for the local player, they are where they're supposed to be. So there is no rewinding on the local player itself. So here I'm just drawing with a different color, whether it's a server or the client, where they are. And at the end, I am applying a gameplay effect, which is GE impulse test. Uh, we'll go back to impulse test later. I'm pretty sure you're kind of excited for that one too. So back to showing you the result of the targeting. And I'm pretty sure you can see the yellow. Yeah, see, it's yellow and it's exact spot. It's perfectly exact spot. And I have 140 ping, something like that. I'm not ignoring myself in these. I'll fix that. So now back to this. So we saw the enemy, we found this location, we did everything we need. Now it's time to apply the gameplay effect. So this apply gameplay effect, it's an impulse gameplay effect. And this adds something called, something new. It's a new component called base movement effect component. This component comes with, again, another processor. Seems like I like using this word processor, but this is another instance object that allows you to just arbitrarily create and pass a layered move or an instant movement effect to be applied to the target of this gameplay effect. Okay, that was a mouthful. Let's try to say that a little bit slower. This will let you apply any kind of movement effect or layered move to the person that this effect is being applied to. So right now I'm applying an impulse. And if we go look at this MEC, which is a move effect creator, effects, no, it's not in effects, in layered move creators. And here's what we're doing. We're getting the effect spec, we're getting the effect context from it, and from the context, we're not really doing anything except getting the origin from it. So when you do target data, when you use target data, the origin will be defined by the target data. So because in Showcase I'm just using the target data to apply the gameplay effect, which can apply to multiple at the same time. This obviously you can make your ongoing spec and make outgoing spec actually gameplay spec, and you can modify whatever you want to put data inside of your effect context and then apply it here. So this gets the context, gets the target mover component. So this kind of expects that the target has a mover component. Should check for validity here. Uh, Gets the actor location, so the person that this effect is being applied to. And gets the origin of the effect context, which in this case is the center of the overlap that is being done. So from there we get the distance and we normalize it based on the distance. If the distance is at 0, give me a 1000 impulse. If it's at the 150 maximum, give me 600. We're keeping the Z directly as the impulse too, so we will always go up and we see it. And we just apply a velocity effect here. It's instant, it will end immediately, so there is nothing special about this. However, this does allow you uh, using a special there is a layered move, specific layered move substruct that I have created that you can create from, which is then uh, effect ability effect layered move. There is an example of a move too, but I can create a lot more examples. But this example, this struct is unique in the case that if that struct gets applied, if that layered move gets applied through this component, it will have the ability to do these two things: to stop when the effect stops, and to pause when the effect is inhibited. So if you use these, you don't have to think about the relation between movement and abilities. Meaning that if you have an ability that stuns an actor, and it just adds a layered move that sets his velocity to 0 and disables all of his inputs, that actor will have the ability to be cleansed and thus immediately removing the stun from him automatically without you thinking about it. This is really important for complex behaviors of enemies and affecting enemies, etc. I think that is it that I wanted to show you. This video is 40 minutes. That's a very long video for a showcase, but this is the best that I can do. Apologies for the length of the video. Uh, so I still do want to say just a couple of few things. As you can see, what's possible when it comes to the interactions between movement and abilities are limitless. Like you can create a lot more. And keep in mind that I was already constricted by the way that the ability system component is built. So within these constraints, this stuff is possible. So without those constraints, there could be a lot more things that are more intuitive and easy to use. So I do believe I can do better than just gas and NPP. Uh, I want to make a dedicated fixed tick simulation plugin. So it will work seamlessly with Mover, with its own backend. It will allow you to more easily create simulations. Uh, this ability system simulation, for example, has a montage simulator, which is like an idea of sub simulations. A montage simulator has a projectiles. There is a very performant on the bandwidth projectiles that uses trajectory and doesn't replicate its location and rotation every time. It only replicates it when it's different from the already predicted trajectory for that projectile, hence hitting somebody or something like that. Uh, there is a lot of things that exist here. The number of tasks is not that huge, but still a considerable amount of tasks. A lot can be added. Um, so yeah, uh, I am open for work. If anybody wants to use something like this, if you're a studio and wants to implement something like this or want to build an in-house solution for this movement and abilities, creating a multiplayer game, uh, my Discord and my email are in the description. I want to say, please don't be discouraged about using Mover. Mover is an experimental plugin that is true, but the more people use it, the more effort Epic will put into the plugin. The more people use it, the more bugs and issues and limitations are found early and can be fixed earlier. So if your project is still new, if you are not seeing your release very soon, if you don't have already created your solid foundation and you're still looking at what to do, which systems to use best, try using Mover. Don't be discouraged. It is our duty as people who are using practically free software to try to help make this software better. That's my take on this. Okay? And when Epic releases something in experimental, that doesn't mean that it was just made right now. They have been working on it for quite a while to release it to the public. So please, if you can, try Mover. If you need help, if you have any questions, the Discord server is open for everybody, and I try to be helpful and friendly with everybody. With that being said, I want to give special gratitude to Maxime on Discord, who has been a paid member of my Patreon page for nearly 4 years and is currently the only one. I really appreciate you, man. Thank you very much. And that is it from me. If you have any questions, if you have anything you want to ask, Discord is open for everybody. Thanks to every person who is already in the member of the Discord of our almost 1,000 people community. I appreciate you all very much. Thank you guys for watching, and I will see you on the next one. Bye bye.